Hey guys, Ninja here on the Randonarchy channel, and today we are going to be playing just a game called Atom. I found it on Steam, it was 99 cents, and I thought, might as well because I'm a nerd. And since it's not really much of a game, I thought I'd put it on the Randonarchy channel, so whoever actually views this, I'm surprised you even watch this channel. But anyway, so basically it's an Atom simulator, and I'll have to explain things to you. But as you can see on the top here, we have different wavelengths and stuff. This is just going to show you the different kinds of light on the spectrum that this element will give off, or whatever we make. I'm pretty sure it's just hydrogen, so I think this is all hydrogens. But we can go into 2D. I'm going to stick with the 3D though. And then over here we got all this stuff, which I'll have to explain to you guys. As you see, if I do this though, it's going to shoot out photons. Or it did earlier. There you go. I don't know why it's making those noises, but it goes straight down to here. Tell me well that you just turn off spectrum and everything stays. But yeah, so these are what we like to call quantum numbers. So N stands for the amount of energy levels, and all of these help you find out where an electron is. So N is the kind of energy levels. Basically, on the traditional atom, you would see lines around it for the different orbital levels. Those are what that represents. The outermost one is the valence electrons, but they don't look like you guys think, and I've been taught. And even though you guys have been taught that electrons spin, they actually don't orbit. They have a probability cloud where they are most probably going to be, and they're only in those areas. Now, what I didn't know is that, well, until I took chemistry, there is a lot of different kinds of orbitals. And so N is just the amount of energy levels you have. And I'm pretty sure that's the nucleus right there, but I could be wrong. That could just be the innermost. This is the kind of orbital. So, go. Now, the way that you see what kind of orbital you have, you basically need to... Okay, hold on. Let me just do this thing real quick. But yeah, so there's different kinds of orbitals, and then M, and I'll show you guys some in a sec, but M is the orientation of those orbitals in space and where the electron's going to be in one of those. And then the spin is only positive or negative, negative 1/2 and positive 1/2. Those are the spins that the electrons can take. So this is a form of quantum mechanics, but it's also a form of chemistry. No, these things are called electron configuration, and that is basically what tells you where everything is. So if this thing would... So I'm pretty sure this is hydrogen is what it said. You can get this game on Steam. I will have a link in the description to it. It's only 99 cents. It's not really a game. It's like a simulator, but you know. Okay, but anyway. Let me just get this up for you guys. Should have had this ready. Okay. So I'm pretty sure you can see my mouse here, but I'm not entirely sure what it's over. So if you look at, let's say, hydrogen, that's going to have an s orbital, which is L1. L2 is an s or p orbital, which the yellow ones have. And the s orbital is all the red ones. And then all the yellow ones have a p orbital, which is L1 or 2, so it has both of those. L3, it has the d orbital, which is the blue, and it has all of those. And then 4 is f orbitals, and it will go so on, but I don't even think it's possible to have orbitals higher than that. I mean, it's nowhere on the periodic table, but f will have all of those. So per se, I don't know. Gold, you guys know gold. 79 AU. It originally is Aurum, but they changed it. I guess I'm not entirely sure why. So we'll take hydrogen and helium, and we'll have... Oh, and the energy level depends on the line it is. I'm not entirely sure how to explain that, but hydrogen is H. Let me just get some text here. Hold on. So we'll have H2. All right, let me just move this to right over here. No. That is totally wrong, guys. Don't listen to what I was saying. I forgot. 1s2, and that second one will actually be a superscript, so exponent, but I can't really show that here, and I'm not really going to use the caret because I don't care to. So we're just going to do this. And we'll just use spaces to show. 1s2, that means helium. And then 2s2, beryllium. And it starts at 2 for the p's, so 2p6 for all of those. And then 3s2 for magnesium. And then 3p6 for argon. And then 4s2 for calcium. And now it starts off at 3d. Yes, pretty sure because it goes 3, 4, 5, 6. Wait. Let me look at this. Okay, so I'm just going to paste golds here, and I'll explain what this means. Really, this means you have xenon's electron configuration, which is all of this, but they shorten it down so you don't have to write that out because you can't really read it. And then it goes straight from here to, let's see. Yeah, so 6, 7, 1, 2, 3, 4, 5, 6. Maybe it does start at 4. I'm not entirely sure, but this would be 4F, and this is 5F. So 4F, 14, all of those. And it goes straight to here, 5D, so 4, 3. No, it does start at 3. 3, 4, 5, 6. I don't know what I was thinking. And then it would go all the way through here. This is missing some things. Oh, wait, no. Yeah. Then they would need 5p6. I don't know where that's at. Anyway, that's basically what all of those mean. Now let's get to the actual stuff. Alrighty, let me just... Okay, so right now we have 5 energy levels. So this is looking to be 5. It's 2 here, so here's 5s, I'm guessing. what 5s would look like. And then 5p. Okay. So this is actually 5p1 because this makes it the next element because that superscript is what the orientation is. So if it's 6, like say it's neon, well, it's going to be a 2p6. Well, let's do that. 2p. Okay, maybe not. I'm trying to see how I would. Why is this not exactly working? Because, let's see here. Try my best to explain this to you guys, and I'm not even doing. I'm doing terrible. So the L keeps wanting to add more orbitals. This is just the energy of the electron, basically. But I'm not sure what the phases mean. I'm not too sure about that one. But okay. Here we go. Well, anyway, these glowing areas are where the electron should be. And then these will bond with the orbitals of other ones. And we're not entirely sure. Like, no one is really able to explain why. Arvin Ash, he explains things simply. He did something that actually kind of intuitively makes it make more sense, so you guys should check him out. But it's like, why are they energetically, whatever the word is, like just wanting to come together? Because we know that they will bond to form molecules and then eventually other substances and ionic compounds and crystals and metals. But why? Well, I couldn't really explain that to you. No one really can. It's really tough. They just say, well, electromagnetic force, because they're near each other. Is it just by chance that they hate each other? Maybe, but like, there's something more to explain that. I'm gonna check out what these phases mean. So I think phase might be where it's at in its life. No, because it's like shining. Looks like it's like a star, possibly. Well, we're gonna do this. Just shrink it about to here. See, the spin affects what it does. Really just its orientation in space. Okay. This wants to change it to look like this for some reason, which I'm confused about. Okay. So I think that's the max we can get it to be. Holy. I don't even know what this is anymore. Yeah, quantum things are very, very confusing. So let's try 2D. See what that looks like. Okay. And then if we do 3D, let's put the phase at 0. Looks like we were just watching it from here. And we're going to miss some of it because there is most of that. But yeah, it's so strange how all these different things, given the different properties they have, somehow. It's crazy. So, by the way, did you guys know that you can taste protons? When you're tasting something sour, you basically have an acid. And what that acid does is it's an exchange of a proton. So, yeah, you're tasting the proton. I don't know how to explain it. Hank Green did it way better than me. Anyway, if you guys want to check out this game for yourselves and play around with it, I will have a link in the description. And if there's anything you want to see me do on this channel, just make sure to comment and request it, and I will consider. On this channel, I would probably maybe do some games that I wouldn't do on the other channel, but big games I'll mainly do on my other channel. This one I'll do reactions, challenges, and a bunch of other stuff. So comments away. And in that case, I'll see you guys the next